Last time we started section 4.1 and we had a fun activity at the end, right? Where you got to discover why the divisibility rule for 6 works, whereas it wouldn't necessarily work for every composite number. I'd like to run through just super fast what those divisibility rules are again, so that you can remember as we are moving into our first actual example on each of the divisibility properties. So the ones that I'm referencing are the ones that are divisibility tests. So the divisibility test for 2, you know it's divisible by 2 if it ends in 0, 2, 4, 6, or 8. For divisible by 5 if it ends in 5 or 0, and divisible by 10 if it ends in 0. And these all kind of get grouped together because it's all looking at just the ending number. 4 and 8 get grouped together because it looks at the last 2 digits or the last 3 digits. So if the last 2 digits as a 2-digit number are divisible by 4, the number is divisible by 4. And if the last 3 digits as a 3-digit number is divisible by 8, then the number is divisible by 8. 3 and 9 get grouped together because they're about summing the actual individual digits. So if we sum up all the digits and we're divisible, the sum is divisible by 9, then the original number is divisible, the sum is divisible by 3, then the original number is divisible by 3. If the sum is divisible by 9, then the original number is divisible by 9. Everybody loved the divisibility test for 11. Actually, you probably didn't mind it once we did it. You look at every other digit and you add up those digits, and then the opposite of those that you added up, and then you subtract those 2 different summations. If the resulting number is divisible by 11, then the original number is divisible by 11. And then the divisibility test for 6 is the weird one that we ended with last time. Not so weird, but just that it has this ability that this idea is more general than just for 6, but it's not so general that it's for everything. So the divisibility test for 6 says that if it's divisible by 2 and 3, it's divisible by 6. And where we looked at last time is we talked about the fact that when we have any 2 numbers that have this relationship that they don't have anything besides 1 that divides both of them, then this property will hold. So we created lots of examples. We also looked at things that don't work, and in every case where they don't work, it's because they have a factor in common. Everybody remember all that? Okay, so what we're going to do is we're going to take a look now at example number 1. Example number 1 wants us to decide, without using a calculator, whether this number is divisible by each of the following values. And you'll notice that we don't have a divisibility test for everything, right? Like there's no divisibility test here for 7. So this is not an all-encompassing, we can do it for every kind of divisibility, but there are just some nice ones that we can do it for. So what we're going to do is we're going to go sort of down the list, and we're just going to decide whether it works. So is it divisible by 2? No. And for the problems in your book, they just ask you to say yes or no. If I ask a test question off something like this, I will ask you why. So make sure when you're writing down your yes or no, you at least know the why, whether you write it down or not, but you know why you're saying no. So why is this one not divisible by 2? It ends in an odd. That's right. So we're going to go through our list. 3's next. Yes, and how did you decide?
3 plus 4 is 6 plus 1 is 7 plus 5 is 12, which is divisible by 3.
Okay, so the sum is 12, and 3 divides 12. Remember that notation, divides means just this vertical bar, and we read it from left to right. So 3 divides 12. So since 3 divides 12, then 3 will divide the original number. How about 4? No. Again, why not? Yeah. So as we're looking back up at this one, I'm going to write down those details. 2 did not divide 5 at the end, and 4 does not divide the 15, right? Yep. Yes, ma'am.
Why did you put a 6?
Where did I put a 6? Did I write something down wrong?
Is it 2 plus
4? I think I was on the wrong
You said 2
spot
plus
on my
4, and then you just thought of 6.
I heard somebody say 2 plus 4 is 6, and then I just kept going. That's what it was. Thanks, Holly Ann. And I think it's okay now, though. Is it okay? Fabulous. How about 5?
Yes.
Yes. And why? Yeah, because it ends in 5. That's one of the 2 numbers it can end with to make that work. How about 6? No, why not?
It's not divisible by 3.
Yeah, because 2, actually I'll say it the way you did, because it's not divisible by 2. It happens to be divisible by 3, but we need both to be true, and this one doesn't work on both counts. How about 8? No. Why?
The last 3 digits isn't divisible.
Yeah, 8 does not divide. Is it 0, 1, 6?
It's
0, 1, 5. All right, okay. One real quick observation for you, just another fun fact for the day, if you will, is that if something's not divisible by 2, it's not going to be divisible by anything even. That will never work. So the fact is, when we ruled out 2, we ruled out 2, 4, 6, 8, 10, 12, 14, 16. We ruled them all out as being factors. So just so that you're aware. It's just another fact. And then I think 10's our last one. Nope, 9, and then 10, 11. 9. Yes, sir.
Whenever, if we ever have one of these on the test, can we put that for why it's not divisible?
You could.
4, 6, and 8?
Yeah, that 2 doesn't divide it anyway because that's enough. Yeah, it is sufficient for sure. How about 9? No. How come? Yeah, the sum of the digits was 12, right? And 9 does not divide 12. How about 10? No. Why not? It doesn't end in 0. And 11, we're going to have to do a little work for 11. How did you decide?
I added 2, 0, and 5, and then added 4 and 1, and subtracted those two numbers, and it was not divisible by 11.
So 2, 0, 5 is 7, 4 and 1 is 5, and then when we subtract 7 minus 5, I get 2, and 11 does not divide 2. One thing that occasionally comes up, it's in a homework problem or a group work problem. If for some reason at the end here when you subtract you get 0, 11 would divide 0. Everything divides 0. So you kind of get it by default, but every now and then I have questions about that and I'm like, wait a minute, I got 0. 0's okay. It would work. Okay, so we're going to look at some other divisibility things that are not specific numbers like that one, but I wanted you to see one of those. We're going to classify each of the following as true or false. Remember when we looked at these definitional sort of theorems, I guess, whatever, I talked about this if and only if statement and how it works one direction and the other direction, and so you have to be careful on your logic and how it works. So this is actually sort of asking you to think about the logic of the way things work. So if a number is divisible by 6, then it is divisible by 2 and 3. Is that true or false? That's true, and it actually fits our property, that theorem. What number was it? Theorem 411, exactly. Like that is what one of the directions of 411 does. How about part B? If a number is divisible by 2 and 3, then it's divisible by 6. Also true. That's the other direction of theorem 611. Okay, those are the two directions of the if and only if statement. Now, C is quite similar, C and D, right? I'm talking about 8, 4, and 2. But I'm not talking about the exact number 6. And 8, 4, and 2 is one of our examples, or 8 and 4 rather, were one of our examples. I still didn't say it right. 2 and 4 were one of our examples, or a similar example to why it's not going to work to be divisible necessarily by 8. So let's take a look at this one specifically because one direction of this is true and the other direction is false. So it says if a number is divisible by 8, then it's divisible by 2 and 4. That is true because what you know is that if the number is divisible by 8, those last 3 digits as a 3-digit number have to be divisible by 8, which means the number had to be even to begin with. So it works. You get it for free. And the reason you get it for free, and it always works in that direction, is because 8 does in fact break down into 2 and 4. So that direction always works, even if the numbers don't have the same properties that like the number 6 did. But this other direction doesn't work. The number divisible by 2 and 4 is not always divisible by 8. And as you know, I like to ask for counterexamples, right? So can you give me an example of a number that is divisible by 2 and 4, but it's not divisible by 8? 12. 12 is a perfect example of this problem. 2 divides 12, and 4 divides 12. No problem, right? But 8 does not divide 12. And remember, divides means it goes in evenly with no remainder. That was our definition from the very first part of this lesson. Okay, does that make sense? Yeah, and of course the reason it doesn't work is simply because 2 and 4 actually have a common factor, namely 2. And we ran into a problem when we look at those types of numbers. Taking a look at another type of problem, we're asked to decide if the values are divisible without actually dividing. And they are using very specific examples as they ask this. It's not just randomly selected numbers. Because, well, I don't know about you, but we don't have a divisibility property for 19s and 17s, so that seems like a far-fetched sort of a general question. But they're asking for some very specific numbers to make decisions about. So in the first one it says, is 34,051 divisible by 17?
Yes.
Yes. How do you know so fast, Colton? You're right.
Because 34 is divisible by 17, and so is 51.
Okay, so 17 divides 34, and 17 divides 51. And we had a breaking up and bridging algorithm for division. Do you remember that one? You know, back in the last chapter, which, by the way, I still haven't gotten to your tests, so we're shooting now for Friday. That's the plan. But yeah, so if I break this apart, this one actually breaks up really nicely. 34 evenly divides, 51 evenly divides. The 0 is irrelevant in terms of division because I just get zeros, no problem. So yeah, this one works just fine. How about 19 dividing 19,031? That's a no. So Catalina, looked like you were saying no.
Well, because 19 doesn't divide.
Yeah, so the 19 divides the 19 at the beginning. That's like good, right? These are like checks off the boxes or whatever. But 19 does not divide 31. It just doesn't. If it had said, what could it have said and it worked? 38. Yeah, that would be the number we would kind of be sort of shooting for or looking for. C and D. The goal on C and D is not to look back at the directions and say without actually doing division. So multiplication works and now I'm going to multiply things. That is not what the goal is. The goal is to be able to look at it kind of like we did the last two and just say yeses or nos. So is 2 times 3 times 5 times 7 divisible by 5?
Yes.
Yes. Why? Yeah, because in the factor multiplication, it actually says there's a 5 in it. And that's what it means to be divisible by. It means it has it as a factor. So yeah, this one works. And it's because 5 is a factor. And because 5 is a factor, of course, it also means it's going to end in a 5 or a 0. It's going to force that, right? And so I'm going to end in 5 or 0 to be the divisibility by 5 if you did multiply it out. How about 2 times 3 times 5 times 7 plus 1? No, why not?
Because it's a plus 1.
Yeah, the plus 1 at the end will cause, there's lots of ways to do this. This is one way. It to end in 1 or 6. All right, we talked about the fact that multiplication by 5 forces it to end in 0s or 5s. But then you add 1 to that, you're going to end in 1 or 6. There is something that we could see. What if they asked us the same type of question, 2 times 3 times 5 times 7 plus 15? That would work, right? Because there's a 5 that divides the first number and the 5 divides the second number, both pieces of it. So we'd be good to go in that process as well. So it's not just because of the addition, but it's because of what we're adding that makes it not work. All right. If 24 divides a number, what other numbers would have to divide that number? 2 would be one of them. How come?
Because if an even number can divide another number, you know that 2 can at least divide that number.
Right. So 24 is even, right? So 24 has as one of its factors a 2. So all of the numbers that are divisible by 24 will as well. But the cool thing is these things occur in pairs. So if 2 will divide it, what else will divide it? Yes, but I wasn't thinking about that. I want to put them in pairs. 12. Somebody said it. Who was that? Was that you, Tiffany? 2 and 12. It's just really nice to pair them as you go so you don't actually skip one, because if you're not putting them in pairs, they always occur in pairs. If you're not putting them in pairs, it's really easy to skip one just because you're moving quickly through it. So 2 and 12 work. Somebody said 4, which is true as well. 4 and what? 4 and 6. What else? 3 and 8. I'd like to reorganize this because if I put them in order, it helps me to see one more fact that I haven't mentioned yet. If you take a look at this, 2 worked, 3 worked, 4 worked, the next number in the list we would try, in theory, would be 5, which doesn't work. And then when I get to 6, it just goes back around to the other side of my list because I've put them in pairs like that. There is one other number that divides it. It's not a very interesting number, but do you know what it is? Yep, 1 also works, and it still occurs in pairs, 1 and 24. So it's just that I already had the 24 on my list, so to speak, but 1 works, so we need to list it as well. But 1 will always work, right? It will. Okay, from a little bit different perspective, those properties from last time. We're going to make a number divide in a certain way. So the number we have so far is 543,220 something. And we want to fill in the blank of the last place so that the number will divide by the following numbers, in particular the number 2. What would I need the last digit to be? The placeholder. 2 would work. What else would work? Any even number. So, does that look okay, Katie? Are we all good? Yeah? 0, 2, 4, 6, 8. How about the number 3?
3, 5.
Okay, 3 and 5 can't both be right.
You could put 2 conditions, that's the addition of all.
Okay, so what you did something before this then. What did you do? You added them together. Okay, so the first thing that you did when we're talking about divisibility by 3 is you figure out what they add up to already. So 5, 4, 3, 2, and 2. And what is that sum, Michaela?
Oh, that's right.
16?
14, 16.
Yeah, 16. Okay. So is 16 divisible by 3? No, so I'm going to have to add something to it to make it work, right? What would I have to add? What's the smallest thing that I have to add? 2. I think that's where you were getting your 2 over there just a minute ago, Colton. So the answer so far is 2. 2 works. If I add 2 to it, I get 18. Are there any other numbers that will work? 5 will work. How did you decide on 5?
Equals 21.
Yeah, it equals 21 when you add it
Just
in.
keep adding.
You could. We have a pattern, right? An arithmetic pattern, and we've seen those before. So 2 works, 5 works, 8 will also work. You can either test each number one at a time, which is fine, or if you recognize a pattern, you can finish your pattern out. So 2, 5, and 8 are my answers on this one. How about 6? A number divisible by 6.
2 and 8.
2 and 8. Why is it 2 and 8?
Because the 2 and 3 both have in common.
Yeah, this feels like a Venn diagram now. What do they have in common? Where is their intersection, right? These 2 lists have a 2 in them and an 8 in them. So those are the 2 numbers that would work in that place. Okay, another logic type of question. If a number is divisible by 5, can it be divisible by 10?
Depends.
Can it be?
Yes.
Yes, it can be. Must it be? No. So can you give me a can it be? Like, can you give me one that works? 20. So 5 divides 20 and 10 divides 20. So we're good to go, right? That is a can it work. Must it work? So in order for you to answer something is a no, it means you have to show a way that it doesn't work. So can you give me an example where it doesn't?
25.
25. So 5 divides 25, so that's one of them. But the problem is that 5 does not, said it wrong, 10 does not divide 25, right? Yeah, so it doesn't have to always be true, but it sometimes is. Half the time it is, in fact. If a number is divisible by 10, can it be divisible by 5?
Yes.
Yes. And again, in order to say yes, I just need to get an example for the can it be, right? So can you give me an example?
50.
50. So, I put that in the wrong spot. Let me shift it a little bit. 10 divides 50. 5 divides 50. So that's an example. Must it be?
Yes.
Yes. Why?
It's always about 10.
Yes, that's one way to say it. That's one option. So let me put that one down and give a couple options. So you said because 5 is a factor of 10. So saying it that way is sort of the perspective of what we were doing kind of like on this problem where they occurred in pairs over here. If it divides by something, it will divide by all its factors as well. You also could go back to the properties themselves about division. So what does it mean for a number to be divisible by 10? Yeah, so you could say that it's because it ends in 0. Which means 5 also divides it, because that's the rule for 5s. Okay, fun little trivia type question. You guys have seen these crop up occasionally in section C's in your book, right? This one's like this. A number in which each digit except 0 appears exactly 3 times is divisible by 3. For example, 777,777,555,222 or 414,143,313 are divisible by 3. Okay, so do you understand the types of numbers they're describing? The digits just are in there 3 times. Why is this true? First of all, go ahead. Did you want to say something?
No, I was just talking about
Because
this.
each number is listed 3 times.
So why does that mean? What does that tell you, Michaela?
Aren't they all in different place values too? So
The place values don't matter though because we're working with divisible by 3.
How do I explain it? They're like, because there's 3 different, it's gonna be triple.
Yeah.
They'll all be
Say that a little louder, Catalina.
If it's triple, then it's 3.
Okay, so let me just take the first example.
Yeah.
Okay, divisibility test for 3 says I add all the digits together, right? So I'm just going to add 3 of the digits together that are matching so we can see this work. So when I do this, this is the same as having 3 or a triple number of 3s. There are 3 7s, correct? But if you multiply 3 times 7, is that going to be divisible by 3? Yes, because there's 3 of them, and that's what division by 3 does, is division by 3 breaks down the fact that there were 3 to begin with. So this will in fact divide by 3 because there's 3 7s. So if I said there were 6 7s, that'd be great too, because 6 also divides by 3. But it's simply because there are 3 of them. And that's why in the property above it says something about with the exception of 0. All that's talking about is it doesn't matter how many zeros you have, because 0 doesn't get any, glory when it's added to anything. Nothing happens, so it doesn't really affect the problem. So this is why it's true. So let's write it in some words since I've only written down the kinds of things that I would send back to you and say explain better on a test, right? That's what I would tell you to do, right? Explain in words. So every number is added 3 times. Hence, 3 times the number. That is a number sign too, just so you know. It's really not a hashtag. You guys have hijacked it, Your generation has hijacked my symbol. All right, 3 times the number. So it has a factor of 3. So the sum, I should say, the sum has a factor of 3. And so divides by 3. Must this statement be true for a number to be divisible by 3?
What do you mean?
Do you have to have 3 repeating numbers of every digit in order to have a value that's divisible by 3? No. So why not? Yeah. So the easiest one right now is actually the number 3 itself. But certainly 3 divides by 3, right? But I like 6 as a better example just because we can distinguish it. 6. 3 divides 6, but it's only one digit. And if you feel like maybe that's sort of cheating because it's really small, maybe if the number's big enough, it doesn't work like that. It's not true either, because we had an example over here that was pretty large, like 543,225, 228, right? And 543,225 does not have every number repeated 3 times. So we saw an example of that in the last couple of examples before too. And we could use that as an example too. So we could say, or, if you want a big example, we had, what was it? 5s first. 543,225 works, but does not have three 5s. I'm going to use the word 3. 3 5s. Or 3 4s, etc. It's not a true statement that it has to have them. It works, but it doesn't have to be true for it to actually be divisible by 3. Any questions? All right, we're going to take a look at group work, section 4.1. I'm going to keep you in the same groups for the moment because I usually do reassignment of groups once I've graded the test, and I'm still working on that. So go ahead and find your people from last time.